Hello, hello, good afternoon. Thank you for joining us for this last talk of our day. It's been a very, very busy morning here in Europe. It's even earlier in America where we're connecting right now. It's always fantastic to have testers from all over the world to meet with everyone in the community. I'm so happy about having this talk for everyone to enjoy. First, as we always do, just let me say hi over here. We have I might say it wrong. I'm gonna try. I would say Matthias. Maybe it's Matthias, but yeah, Matthias. How are you? Greetings from Germany. Dot has been with us through the full day. Thank you so much for being part of this day, for participating. Hello from sunny UK. Hope it was sunny over here. Thank you to everyone that has already joined us. We have Jarmo, Jurgita, the Thomas, Jens, Soren. How are you doing? Marcus, Anka, Jode, Victor, I've seen you before today, so hello as well. Mohammed, saw you in the first one, if I'm not wrong. Thank you for joining us all the way here. Matthias, Matthias, Job, Susanna, Marwan, you were always also here earlier, I remember. So thank you, everybody that has joined us. For anybody that doesn't know, I just need to share this with you. There's nothing like connecting in person. Online is perfect, and it's very good because we can work. We work from our houses or from our offices, and we're fine, but there's nothing like connecting and networking live. So just for you, for the community that joins us, I always like to have something, and this time you have a 10% discount on coming to Automation Stars. So if you want to grow your network, you want to grow your knowledge, you want to be part of giveaways, you want to be part of a great conference. I promise it's a great place to unite with other testers and to connect with the community. Come to Automation Star. We'll be there in Amsterdam, 10 and 11 of November. And just use this code webinar10. You came to the webinar event, you enjoyed it. Go there and make the best use of it. But it's time to go in. I think we are ready. And I am very, very happy to have here Nishan. How are you doing?
Hey, morning, Joe. Doing good. How about you?
Not too bad. Thank you so much for being with us. It's very early in America, right?
Well, it's 8 a.m. It's about early. Yeah.
Yeah, yeah, early enough. Thank you so much for your kindness for being here with us. And my last recommendation is to go full screen with this presentation so that you can enjoy it the best. And virtual floor is your nation. Thank you so much.
Thank you. Thank you so much for that. And very good morning, good afternoon, and good evening, depending upon where you are joining us from. My name is Nishan Joseph. I oversee the sales, engineering, the SecOps, and a part of the products team here at ExcelQ. I'm actually joining you guys from Boston, not so sunny Boston, actually. It looks like it's going to be heavy thunderstorm and rain later today, but none the better. It's good to see so many live audience and enthusiastic folks to know more about our today's topic, which is all about Copilot trap. It's a familiar topic. I'm sure a lot of you have discussed this, have talked about this in the past. And essentially, the intent is to kind of talk about how AI generated, like code based automation is pretty much like not sustainable. A little bit about me. I essentially come from the test automation background. I'm ex Micro Focus, ex Parasoft, pretty much spent the last 15, 20 years in this space. So pretty familiar with the various, testing tools out there, open source, of course, and commercial as well, right? I have a small deck to kind of show you some concepts, some basic high level insights into where my thoughts are as far as the Copilot trap is concerned. And post that, the intent is to kind of showcase to you from a technology standpoint how the two are fundamentally the concepts of marrying the technology and where we're kind of heading out into the world as well, right? I hope my screen's up and visible. And of course, if there's any questions, put in the chat, or we'll be having probably a Q&A towards the end anyways. Now, probably not the best topic to start the discussion with, but I'm sure a lot of people here might be familiar with this. And this is in 1986, NASA launched the Space Shuttle Challenger, right? I'm sure you're familiar with this, right? And this was launched despite um, like internal concerns from the engineers about the failure risks of something called the O-ring sealing, especially during like cold weather. Um, but the launch happened under immense pressure. There are many reasons for why they still went ahead with this. Some of it came from leadership, some of it was politically motivated, some of it was just public expectations. I mean, it was 1986. Um, Unfortunately, the shuttle exploded 73 seconds after launch. And tragically, it actually killed all of the seven crew members on board. Now, the root cause wasn't a single failed part, it was a systemic failure. The O rings had shown signs of weakness in prior launches, even, right? But the decision makers had become kind of accustomed to interpreting these as like noise, these various signals as noise, right? Each individual piece of data in isolation didn't look catastrophic at all, to be honest. But no one really synthesized the broader pattern, right? And that is the fundamental like issue with it. So if I kind of draw a parallel now into the test automation world, these are what I call as the various phases of delusion of an automation engineer. Some of you might agree with this, and some of you might not. It's a hot topic, but it starts with the what is called as the initial spark, right? And this is all about speed over strategy, right? And any organization, essentially under pressure, they need to scale their QA quickly, right? They go ahead, they adopt AI generated code to build their regression suite. And pretty much within weeks, there's hundreds of tests. There's clean code, seamless CI integration. The leadership, ecstatic. They're thrilled. Automation at like warp speed, right? Then comes the next phase, which is the hidden cost of instant gratification, right? And this is essentially, imagine it to be around like sprint three, where like over 60% of your tests are fundamentally beginning to fail, right? And that's where, you know, the questions get asked why, right? And that's because obviously the application has evolved. All apps do. There's new logic being introduced. There's changing APIs. The UI has been updated, right? And now all of a sudden the AI generated, tests were just too rigid or just too isolated and just lack like resilience, right? Move into the next phase, the black box problem, right? This is where the QA engineer couldn't fix what they didn't obviously fully understand in the first place. Why? Because there's no reuse, there's no abstraction, right? There's inconsistencies in the patterns, for example, the logic duplication kind of across like multiple files, even, right? And every test was a one off with no context or no architectural backbone, right? So then this moves into the next phase, which is the regenerate. And yeah, I mean, of course, but regenerating obviously didn't help, right? Because they asked the AI engine to go ahead and regenerate the tests, and it obviously started from scratch each and every time, essentially meaning that there is no memory, there is no learning, there is no ownership, right? What does this mean? Fast automation essentially just became fast technical debt. And I'll touch upon technical debt very soon. This moves into the final phase, which is basically back to the basics. I mean, manual rebuild. It's just basically it's resulted in like crash and burn. And ultimately teams just begin to like scrap the entire AI generated suite. And then there's this dawn of like realization of sorts that the rebuild of tests probably should now take into consideration like modular components. Maybe we should have some kind of mechanism to like centralize the logic. Maybe we should have had more like business context driven like design, for example. And the understanding and common consensus is let's try to do this slower, but try to make this more maintainable, right? Scalable, and essentially let's try to make this like future proof. That's what you want to fundamentally do. What's the key takeaway at this point? AI can obviously write code, but it doesn't understand systems, right? Automation without architecture is just chaos on a faster clock. So just because the rocket launches, it doesn't mean it's safe. And just because the test passes doesn't mean it's built to last. Okay. If we had to kind of look at the AI evolution, and this is where I'm sure a lot of you would, would have a lot of like commonality with over here, right? And the understanding of how we have fundamentally kind of evolved, right? So this is what we call as the AI glow up timeline of sorts, right? And we start all the way back in 1950s with like the Turing, like universal machines, right? Basically, think of it like the great grandfather of like AI who spoke only in like logic puzzles of sorts, right? And then came the predictive like typing era, as it's called, where AI could finally say, "Did you mean duck?" and save us like some level of embarrassment, right? Then came the deep learning, which is essentially kind of showed up around that 2012 timeframe. And it's like, I'm smarter now. And suddenly AI could recognize cats better than like humans could. And then came in the Transformers like era, and this is around the 2017 odd or so. Right? I'm not talking about the Michael, Bay kind, but I'm talking about more like the GPT-2 models, and which could actually write and sound half human as well. Right? And you kind of fast forward all of this into today, and AI is like, painting, it's coding, it's writing sonnets, and basically doing everything except paying taxes, right? And now we're heading into a future of like full autonomous agents, smart, self improving like robots that one day might even schedule meetings and potentially even just attend meetings for us, fingers crossed. So this slide kind of like depicts the six like various like key phases in AI evolution. I'm sure a lot of you are familiar with this, where we begin from the Turing theoretical foundations, the early rule-based like systems like ELIZA, for example, that leads into the predictive era with the decision tree and the recommendation engines. And the real shift really happens, just to recap, around the 2010s with like deep learning, breakthroughs like, if you're familiar with AlexNet and like GANs, for example, and followed by game-changing transformers like BERT and GPT-2 that kind of set the stage for like today's augmented like creativity era, where tools like GPT-4 and Midjourney, and like things like Copilot, for example, are actively kind of enhancing how we work and create, right? So, I'm kind of looking ahead, we're entering the era of like fully autonomous AI agents, systems that can reason across modalities, collaborate with humans, and continuously like improve themselves, like bringing us closer to that artificial general intelligence, as we kind of call it, right? So where does all these various concepts kind of like marry the technology aspect of things? Where does this kind of come together? And that's where a fundamental platform like XLQ comes into play. And if you haven't heard of us, we are an AI powered codeless test automation and test management platform, fundamentally all baked into one. um, all the analysts out there, the Gartners, the Forresters, have all recognized us. They put us in their leadership quadrants, their magic quadrants. But not only have they put us in that magic quadrant and leadership quadrants, they've also given us the highest like rating ranking of sorts, right? And these reports are available. You can even go to our website. You can get the reports and read the reports as to why. We kind of come out at the top and topmost even as far as the rating ranking is concerned from a test automation standpoint. But where is it that this fundamentally, kind of makes sense? And that's where the concept of like how XLQ is transforming, automation with a holistic like lifestyle automation platform comes into play. This lifestyle automation platform is what really powers your entire like QA process from design all the way to execution with like zero code flexibility and AI intelligence, right? The platform fundamentally aligns with the low code citizen development concept, like empowering like business users, like without sacrificing, of course, the enterprise depth, right? And it's tightly integrated with like agile and DevOps, and it's enabling these teams to embed your testing early on, right? And make it continuous as well, right? And this is where the automation kind of like across the lifestyle or life cycle kind of comes into play from a test design standpoint, from an asset management standpoint, from a source control perspective, from a change tracking and governance. It's pretty much like all in one place. And the AI like native capabilities deliver smart, like resilient automation using natural language, self-healing concepts, adaptive like impact analysis mechanisms and the likes, right? And then it's that finally about that, the real-time like cloud-powered platforms, right? Which is essentially kind of built for like this codeless extensibility, eliminating like the need for like code injection even, right? And it works seamlessly across whatever is in your tech stack, like UI, backend, mobile, whatever the case may be, right? And finally, the design studio, which kind of brings all these like things together from a business process to life perspective, right? And it drives like accurate end-to-end test validation, because that's really what you want, the end-to-end test validations, the real world user journeys that kind of bridge that gap between like business and IT. So Excel has always like delivered speed, scale, and simplicity in that sense, right? Now, we've always, the key aspects of where the platform's capabilities come in is the ability to kind of support whatever is in your tech stack, right? Be it any form of web applications, Angular, Flutter, React, and the likes, be it any form of thick client, desktop applications, Windows, POS units, Electron apps, mainframes, be it any form of mobile applications, native, hybrid, web-based mobile applications, be it any form of like backend middleware, so your database validations, PDF validations, Excel validations, email APIs, REST, JSON, Kafka, gRPC, GraphQL, whatever may be in scope, right? And the ability to do this seamlessly without having to know any programmatic language, the natural language, English language mechanisms kind of come into play, right? But then also accommodating all the complexities that the typical like commercial tools also even have out there, commercial platforms have out there, the likes of like Salesforce, Workday, Coupa, MS Dynamics, Oracle, SAP, and the likes, right? And as a user, it doesn't make any difference to you what's in scope. But what we've also done is that we've added an additional layer on top of the natural language, English language, to cater to these commercial apps out there, where we're provisioning accelerators of sorts, right? And these are accelerators which are typically aligned with like behaviors of your application. So a typical behavior in Salesforce, for example, could be, you want to target the URL, you want to enter the username, enter the password, click the login button, you want to tackle MFA. And instead of having to programmatically kind of bring in all this logic, we kind of make that available as a pre-built accelerator or a module classified as what we call as live action, which are always going to be release aligned as well. So from an automation journey standpoint, you are leveraging the aspects of automation not only through the natural language, but also using the accelerators and the likes to fundamentally kind of like building blocks, like Legos. You're putting things together to fundamentally make them reusable, make them referential in nature, make them centralized, make them available in a collaborative environment, so that everybody else can also have access to it, right? And AI has been an inherent part of the platform all through. The traditional platform capabilities have always had, whether it's the AutoCAD, test case generation, the element handling, the bot, healing, the natural language. But over a period of time, this year primarily is where we've introduced Autopilot, which is where real the evolution of sorts of technology really comes into play, right? And this is where fundamentally, XLQ's like Autopilot is our next gen AI powered engine that drives continuous self optimizing automation. It transforms the way how teams build, execute, scale their tests, automation, and it's all, of course, combining these natural language AI-led designs and smart self-healing concepts and the likes, right? But if I had to kind of give you like a high-level insight into what does this kind of entail, it kind of all starts from our scenario discovery like engine, right? And this is where the business flows are captured via live recording or plain English language instructions. Then our full stack, natural language automation builder kind of generates automation logic across the tech stack without having to kind of rely on flaky locators and irrespective of what technology is in scope, as we talked about before. And that generates that automation logic across the tech stack, with then coming in the design first architecture, which is all about creating modular, reusable, referential, integrity based, centralized assets, which is important, right? And make that provisioned in a collaborative environment, and essentially ensuring that your tests are tests and test designs are all going to be like scalable, including the likes of if you're doing like synthetic data generation, for example, right? And during execution phase is really when the autopilot brings in that self-reflection of sorts, where it's like optimizing like parallel runs across devices, across browsers, environments, and even with like service marking, for example, right? And that's where eventually brings you that AI powered like insights or analytics through dashboards and screenshots and pretty much like instant like defed logging and the likes. And eventually you will see the power of like semantic self healing that triggers like smart reruns and ensures like reliability. So essentially, me to say that from discovery to like reconciliation, XLQ's autopilot ensures like continuous optimization and making essentially your tests automation, self-aware, self-healing, and deeply intelligent, right? And that's really how our customer base has also been completely, across the industry verticals that you're familiar with, be it from some of the largest financial clients out there, from like, Wells Fargo, Comerica, Barclays, M&T Bank, and the likes, to some of the largest healthcare logos out there, to United Health Group and Optum and Rally and Anthem and the likes, to some of the largest in the airline space even. So Etihad and United Airlines and Southwest and the likes, to even heavy presence with the federal within the federal government ecosystem as well, right? So some of the largest banks out there, Federal Reserve Bank, for example, all of them users, even their payment gateways, their business lines, even users, and to U.S. Department of State, and many are fundamentally utilizing us as well, right? But I do actually also want to kind of show you what the platform essentially kind of looks like, even, right? So that you can kind of get an insight into fundamentally, what to kind of expect, right? So if I had to kind of quickly switch my screen, and if hopefully it is up again now, what you are essentially kind of seeing now is the platform in action, right? And this is, as I mentioned, an AI powered, codeless, cloud hosted test automation and test management platform, fundamentally all baked into one. I'm accessing one of my instances here, which is, where we kind of send all our prospecting clients for POC and trial purposes. But like if you had to become a production customer of ours, you would actually get a dedicated URL, an independently carved out instance at an AWS or GCP instance closest to your geolocation, complying with all GDPR rules and the likes. We follow a named user license mechanism, which means that you can have individuals from your organization be then given a license with specific automation tracks or phases that they can kind of subscribe to, whether it's web, mobile, API, SAT, whatever the case may be. And then once you've done that, if you have tenant admin privileges, you can actually then go ahead and create any number of workspaces or projects, as we call it. And typically, these projects or workspaces are ones that you would align with the specific application, like Workday, for example, or Encino, for example, and Coupa, for example, or SAP. And essentially, these workspaces or projects are collaborative in nature, which means that you can have multiple individuals from your organization tagged to a specific project, and those individuals can then access each other's assets. They can also create, contribute assets on their own, which then becomes a part of the centralized repository, which then others can fundamentally leverage as well as a part of that automation journey. And one of the first few things you do see when you kind of log into the platform is this. This is what we call as a universe. Think of this like a blueprint to your application under test, right? Where if you use page object model, this is like a 10 times more mature version of page object model, where every single asset can be centralized, every single asset is reusable, there's referential integrity between every single asset that's created, there's a modular approach to automation. It goes back to all the baseline principles that I was kind of reflecting that an automation engineer wished we had actually brought in during the code generation process, right? And that's essentially what we have as a part of our platform, right? But this universe that you see is something that essentially kind of builds itself out over a period of time as you progress through your automation journey. And it doesn't really have to do, it doesn't require you to do anything in particular, but it does actually rely on a handful of entities, like these little blue dots. These are like access points to your application. So things like login page, dashboard page, email validation page, whatever the case may be. Those are access points, including APIs, DBs, Excels, anything that acts as an access point. Right? But then you also see these arrows kind of flying across on your screen. These are those modular reusable functions or methods, as we call them. In this case, like a login function is what you typically perform on the login page. It's one where you would enter the username, enter the password, click the login button, tackle your MFA, and as a result, you probably land up on the dashboard page, right? So this is where the logic really lies. This is that reusable component that I was talking about. It also means that as you make any change to any of these components, since they're centralized, since they're reusable, essentially it would also then have the ability for you to kind of transcend all of its changes across all the other modules or workspaces that are also reusing these components as well, right? So that's where these scenarios kind of come into play. So scenarios is nothing but combinations of all these various actions or functions or modules that kind of make up the platform structure itself, or the use case or business place under flow, right? Which is what you see over here. It has that ability to kind of showcase a drill down version of the universe. And then the question that arises, how do you actually go about building the automation? So that's actually where our design studio comes into play. And this is an important piece because I want to show you how easy it is to leverage AI to fundamentally build out your design. And you'd notice that, irrespective of what you're trying to do, you will be able to fundamentally leverage the power of our automation by simply utilizing the design studio, the AI recorder on the right hand side, and you will be able to see that the platform has tremendous amount of understanding with regards to your application. I'm just showing you a Salesforce example just to show you how easy it is. It's identified, for example, this is a button, for example, right? And then it's up to you how you kind of want to go about building automation. Where if you go ahead and right click on any particular component or element within the page, it'll start giving you suggestions. And this is the natural language English language that I was referring to, right? Where it says that, hey, are you trying to click on this web button, which is exactly what I want to do. Or if I'm working with password space, it's saying, hey, are you trying to enter encrypted text into the password input space, which is exactly what I want to do, right? So like this, there's hundreds, thousands of such natural language English language commands. All you have to do is select that specific command of choice. It populates the logic, as you can see, is a natural language English language. It doesn't require any programmatic knowledge at all. And then you can proceed by provisioning it with specific inputs or values that you'd want to. And you'll see that the platform's kind of doing things in real time, confirming that it's done exactly as expected. So you can obviously proceed to build your automation in this manner. I'm not going to go into the depths, but you can imagine that the power of this platform extends to pretty much whatever comes to your mind. And this is where we're intelligence aligned, where fundamentally just start typing whatever comes to your mind, right? So I typed in press, for example. It's giving me a host of options with regards to clicking and combo clicking and scroll clicking and by clicking and whatnot. But maybe what I want to do is interact with a PDF file, for example, where I want to verify something in a PDF file, or maybe I want to interact with a PDF file, for example. Same goes with like working with like Excel, for example. Maybe I want to read right into an Excel file. Maybe I want to compare database with an Excel file. So what we built, I'm not going to go into too much details over here, but we built is that this reusable library of commands that you can fundamentally leverage. But at the same time, if there is an existing full function, action, or module which was either built by you or somebody else, can also be leveraged. That platform builds that intelligence as you kind of progress through, which also means that it minimizes the maintenance. Now, this, of course, extends to a lot more, like email validations. You want to introduce conditional statements. You want to introduce like repeat loop statements and the likes. But then the question arises, okay, this is beautiful. I'm able to do a lot with just, the ability to, provision, interact with my application. What if I want like AI to do everything for me, including create tests, right? So that's where the ability for you to just give it a blurb, give it a high level understanding of what you want it to do. In this case, for example, I'm just giving it an English language set of like sentences which says log into a specific application, navigate to the account summary page, and verify something for me on the account summary page. And from there on, I want you to proceed to initiate a fund transfer, which essentially needs to be completed with specific test data. And then fundamentally, once confirmed or verified, please log out. And I can provision it some high level data as well. This source could be like this, plain English language. It could be from Jira, where user stories reside. It could be from a requirements document. It doesn't matter to us. But what the platform internally does is that it triggers and initiates a process in which it will understand your application under test. It will understand what you're asking it to do. It will go ahead and leverage your automation. Uh, Sorry, I just realized that I'm probably not sharing the right tab. So it will leverage an automation tab. And let me just go ahead and discard this and restart just this process, right? Where I'm actually telling it to go ahead and create an automation based on specific information. Where I'm going to tell it to log into the application, verify something for me on the account summary page, initiate a fund transfer. And again, this is a plain English language blurb that I've given, as you can see, right? And at the same time, this could have been very well from a user story in Jira or my requirements document, etc. And what the platform's now going to do is that it's going to make sense of what you've given it, and it's going to go ahead and proceed to build an automation journey for you, leveraging the power of QGPT and LLM out there to fundamentally ensure that it reuses an existing component or built out module by either you or somebody else up until the point where it has fundamentally understood that there doesn't exist a component or an action or a module, and then goes ahead and creates something net new. So automation that you see here is fully created by an LLM engine, of course, leveraged by with the power of QGPT. And if you go into any of this, you will actually see the detailed logic that even exists underneath the hood of having entered the username, entered the password, clicking the sign in button as the part of the logic for the login action. Similarly, if I navigated to any of the other ones, including, let's say, complete fund transfer, you will see that it has the entire logic of even creating a random alphabetic string of a fixed character, which it's then going to enter as the value, the from, the to, the random text creation for the for the amount, for all of those things, which is then finally pre-populated, and hit the submit button. So all the logic is being created by the engine. And if I kind of go ahead and play back some of these things, you will see that the platform will invoke the browser. It will go ahead and enter the username, enter the password, hit the login button, move to the account summary page, and until it finds something in there and proceeds from an automation standpoint, right? Now, if I kind of show another aspect of this, and this is where I just want to show you another, and if you can confirm, right? We also, in addition, have the ability to go ahead and fundamentally discover entire universes as well, right? And this means that the starting point of this could be pretty much anything. It could be even like wireframes from Figma, for example, back at a napkin, like scribbles, for example. Maybe it's an existing application, for example. Maybe you have the knowledge and predispositional understanding of which domain it belongs to, because it could be, let's say, from the financial domain, for example. Maybe it is specifically from a commercial application like MS Dynamics or Oracle, SAP, for example. And using that baseline understanding, the platform is able to then start to kind of break down your application and understand the various components that make up your application, understand the potential reusability that exists in every one of those components of your application. And once it's identified those components, it starts building the logic for that particular a component in that particular page as such, and then start giving you journeys as such, as we call it, right? And these are like business processes or journeys that essentially kind of take you through the various pages from page to page, or from in your application to application as well, right? So what we're seeing over here is that we're only selecting a subset just to kind of show you a relevance of what this looks like, and this will then go ahead and discover those journeys, those paths that exist from just those very baseline set of like assets that you have asked it to discover, right? And what this is now doing is creating end-to-end flows or scenarios, right, with all possible data generated test cases as well, which is what you see over here. It's generated more than 8 variations of a single flow of having to validate the login. And if I kind of go in to see the logic and the under the hood, what that looks like, you will see that it built out all the functionality, the logic. It has built out test cases with positive and negative, tests as well, and test cases as well, right? And that's really a part of like the automation essence of an automation platform, where you are leveraging the power of AI and LLM to fundamentally build out robust automation within your platform, which is future ready, which is reusable, which is modular in nature, which has the concept of reusability and is provisioned within a collaborative ecosystem where multiple individuals can come and take the benefit of this. So it's not a one time activity, but you're trying to make things ready for the future as well, right? Now that was an extensive kind of showcase of where Copilot as a trap, and then eventually how a platform like XLQ could fundamentally kind of be leveraged as such. I do want to kind of stop here and then open up the panel for any questions that might be there. And if not, I want to leave you with that final thought that says that automation without architecture is just chaos on a faster clock. And I'm a strong believer of this, and I'm sure you can imagine that that's essentially where automation and automation tools should be fundamentally heading towards. Any questions so far? I'm trying to look at the chat as well at the same time.
I think people have been following closely so far. Um, no, no questions at the moment. Are you okay if I ask you one while people get into questions?
Yeah,
And
absolutely.
yeah. Like about the defect tracking capability, does it exist? And are there any requirement integration available?
Yeah, absolutely. So the way we are fundamentally kind of like structured as as well is the very fact that you could leverage the power of all integrations that the platform brings to the table, right? So let's say you have run a couple of tests, for example, right? And if you look at the execution again, which is in plain English language, as you can see, tells you exactly what it did, how it did it, and what passed, and if there were any of them that even failed, it tells you specifically where a failure occurred even, right? And you can go into the details of why a failure occurred, for example, right? But if you do feel like this is something that you want to kind of report as a defect, for example, you can quickly go in. There's integrations available with Jira, ADO, etc., where you can either associate it with an existing defect, or you can create a new defect. You can actually send all the information, pass the entire error logs, attach any screenshots, so that your folks in Jira or ADO can take a look at deeper details of this, right? And fundamentally, and defect integration exists as well, right? And as a part of the overall bot healing, self healing concept as well, if things have actually changed in your application, the platform's able to pick this up and it'll tell you that hey, by the way, at design time what you gave me was different compared to what I found at execution time, but I still went ahead and built out the automation, completed the execution, sorry, but here's the report that kind of tells you how and why this is the case, right? And the same goes with as far as integrating with whatever is your requirements tool of choice. So if you're housing everything in Jira or ADO or Splunk or whatever the case may be, you can actually create a bi-directional traceability right here, where information can get passed back and forth as well. And the same can any test case or test suite or whatever it is that you're fundamentally kind of running. You can choose when you want to run it, have it run right away. You can schedule it for future date and time. You can either make it a recurring job that runs weekly, daily, monthly, or you can make it a part of the CI job as well. So if you are Jenkins, TeamCity, Bamboo, Azure DevOps, whatever is being used right now, we have native connectors for all of these. You can fundamentally just create a CI job here and plug it into your CI tool of choice, and a series of tests can be triggered from the platform as well, right? So to answer your question, yeah, all three defect tracking requirements as well as CI/CD integrations all exist and are made available natively within the platform itself. Okay.
Okay, thank you so much for that. We have a couple of questions here. From Dot, we have the demo looked more like capture for reply rather than architecture. Does it produce modular maintainable testware?
Yeah, absolutely. It's a brilliant question, actually. And it's the way it is architectured is all about creating these like modular reusable components. So while you saw me kind of leverage the power of LLM, for example, and that's one way to kind of build out your automation, you would have noticed that it was fundamentally one where it is leveraging an existing asset first before proceeding to create something net new. And that is the design first approach, where it's going to ensure modularity, reusability, referential integrity, over having to just create something which is throwaway, right? As opposed to being reusable, which is what our baseline principles are all about. And that's why every other testing tool out there, or any other Copilot generated testing asset or test suite out there, is really only creating technical debt for you rather than creating reusable components, which is really how the platform should be structured, right? And the way we are also architectured is that you can always leverage the natural language, English language, and of course, it will do phenomenally well in that space. But then also the fact that it uses understanding of the domain that you're working in. If you're using a commercial app, for example, like Salesforce or Workday, leveraging a live action or reusable action, which is all release aligned as well, are going to be the baseline mechanisms that it will follow to structure to build your application tests as well. So yes, to answer your question, that's essentially the way it is, heavily architectured. Um,
And as a follow up, we have what is meant by self reflection during execution.
yeah, that's a really good question, right? The Some concepts of and again, it doesn't look like I'm sharing. Let me just. Am I sharing the right tab? Okay, yeah. So, for example, look at this. For example, it went through the various steps of execution, where it reached finally the navigate to fund transfer. And what the LLM engine did was that it churned out an automation script that says, look for funds transfer, for example. But then the AI engine kicked in and it's figured that funds transfer doesn't exist. And the closest and best match that's actually fundamentally found is fund transfer. Now, this is a simple example, but imagine if there are bigger changes, right? Where there's massive name changes that happen. Your initially it used to be called login as the button name, but now it's called sign in, for example. Maybe things have moved around in your application. They're not in the same place where they used to be. Maybe things have gone behind something. Those complex changes are all detected, understood, and they fundamentally made sure that, self-healing, bot healing kick in, and then gives you the suggestion saying that, hey, by the way, this is the element that I've detected. Does it make sense? Would you like to go ahead and accept it? And like, if you accept this, then everywhere else, a navigate to fund transfer logic, business functional block is used, will automatically get updated. So all the other workflows that are leveraging this will also get updated. And that's the beauty about reduction in maintenance that the platform fundamentally brings to you, right? And that's a part of the overall process as such, right? I think that I see another question over here about. I hope that kind of answered the question, right? I see another question over here about test users and confidentiality data. Sorry,
Yeah.
this is a brilliant question, and just to make it very clear, we deal with some of the largest healthcare customers out there. We deal with some of the largest financial customers out there. We are the preferred tool of choice for some of the biggest core banking systems even out there, both internally within their organizations as well as for their end customers. So if you've heard of Encino, for example, we are the preferred tool of choice as well, for example. But and with that comes the concept of like data and data sensitivity. There are three ways we combat this. The first way is that we follow a complete decoupled architecture, which means that all your design development happens on the cloud, which essentially means that that's the carved out independent instance that we provision for you on GCP or AWS in either Europe or US or APAC. And that's where you maintain your scripts. Those are natural language, English language, combinations of thereof that you kind of put together. But the actual execution happens on what we call as agents. And these are agents which are fundamentally deployed and can be deployed anywhere, including behind your firewall on local VMs, and you can Dockerize it, you can put on private clouds and dedicated, system. It doesn't matter to us. Essentially, meaning that when it triggers an execution, it triggers it on these agents, and these agents are sitting behind your firewall, And that's the only time at which it will access your application under test, your internal APIs, internal applications, your data, and essentially meaning that no information will ever leave your premises. And that's what makes it super secure. That's the reason why a lot of the banks and financial institutions out there are fundamentally leveraging us. We also have a complete ecosystem of role-based access systems put in place where you can actually create give rather grant individuals specific roles and responsibilities and access rights and view rights, etc., which means that you can actually not only carve out individual workspaces and focus specific individuals within those workspaces and have them collaborate there, but also within the workspace, individuals can have different levels of access and roles and responsibilities as well. So there's multiple different ways, and the third and most efficient way is that you can actually create a lot of data locally within your premises itself, right? Which means that you can actually synthetically like generate data based on a schema or upload a sample or just a high level description, like, generate patient data, for example, right? And you can actually determine like the record count and what file format that you want. And what this will essentially do is that it will actually generate relevant data for you. So if I said patient data, I don't want patient data which just says first name, last name, and home address. I want patient data which is more relevant, which is correlating with age, for example, correlating with past ailments, for example, correlating with potential regional specific like issues, for example, and the likes. And that should be what the generated data should kind of render to me, right? So this is all powered by LLM. It's powered by LLM in the backend, what we call as like UGPT, and of course we leverage Anthropic in the backend and as well. But this is the crux of it. So there's multiple different ways that you can do this, and of course there is the ability to even create generate data on the fly as well. So you can actually generate like random data, first name, last name, or whatever you'd want, fundamentally is possible right here as well, right? But yeah, at a high level, that would be what is easily doable, possible, right here. Sorry, this is on the wrong page. But yeah, I hope that kind of answered the question. Yeah.
Yeah, that's very good. Thank
Yeah.
you so much. We have two more questions there. Another one from Matthias. Can the system run a test case across multiple computers, for example, synchronized with other subsystem simulators?
Yeah, absolutely. A brilliant question. So, for example, if you remember, I mentioned that we follow a decoupled architecture, right? So all your design, development, maintenance, reporting, analytics all happens in the cloud, but that actual execution happens on agents. So depending upon where you decide to run it, you will then see all the various possibilities of execution. Here is an example of where I want to run it up against my Lambda test instance, for example, right? It doesn't matter where. I'm just giving an example, right? And this is when you'll be able to see all the various OS, browser combinations. If you're doing browser on on devices, for example, so all the various OS browser like device combinations, even if they are simulators and emulators, will all show up here. If you're doing native mobile applications, all the various OS and device combinations show up right here. Another fun fact is that if you're doing native mobile application automation, you do not need to maintain different scripts for Android and iOS devices. It's a single script that you'd maintain. And essentially, depending upon the OS and device combination, so if I picked up an Android 16 Pixel 10 to run automation, it will then run an Android specific instance script against the same device OS combination rather than having to, and you don't have to maintain two different automation scripts even. It's a single script. So it's one of the major advantages of using mobile automation within the Excel view front, right? I hope that kind of answered the question. So I see there are some things that, okay, we answered the synchronization with substance simulators. Yeah, absolutely. So you can actually, so if a test is run and, there's a batch job, or if there is, you need to wait for something to fundamentally appear, disappear, you need to wait for something to fundamentally kind of be completed. You can have like triggers set. You can set wait conditions. You can fundamentally have a checkpoint set up. The agent orchestrates a lot of those things. It's an intelligent mechanism in the back end, and there's obviously capability within the platform to kind of programmatically kind of handle any level of change as well, right? All
Perfect.
right.
Thank
So,
you. And
yeah,
yeah,
so I think that's almost all the questions. Hopefully, that kind of gave some level of clarity to everybody. This is really a high-level insight into where technology is really heading out, and we're evolving in this front on a weekly basis as an organization, and obviously, as an industry, even there is tremendous amount, leaps and bounds which are being achieved. So, again, reach out to us. We'll be happy to kind of show you more specific content, around like your ecosystem and how we could potentially address those. I hope this session was at least somewhat insightful in a way. But again, just to like leave you with that last quote, which I'm kind of now potentially maybe a little bit obsessed with, is the very fact that we have automation without architecture is just chaos on a faster clock. And I believe I'm a strong believer of that. Go back to the base design principles, the way we're structured, the way we're architectured. It's really the key core of it. But yeah, thank you once again for spending your precious time with us over here.
thank you so so much, and I hope people will stay in touch with you. Thank you so much for the presentation and for the Q&A. It was fantastic, and thank you to everyone that has joined us through the full day. I think it was a great one. If you couldn't attend to any of the other talks, or you're curious, or do you want to go through it again, I'll be sharing the videos and everything by the end of the week. I won't say tonight. I hope I finished for today, but just I will reach out to everyone. So don't worry about it, so that you can see all these talks again and be in touch with all of the speakers. Thanks to everyone here. Thank you, Nishan. And I hope to see you all very, very soon.
Thank you. Thank you,
See
team.
you.
Have a
Thank
good day.
you. Same.
Cheers.
Thanks
Bye
a
bye.
million. Cheers.